Welcome. We're going to do questions 202, 203, and maybe 204. So let's do it. 202 states we got bears. This is kind of like our whales question the other day. Male bears living in the wild is approximately normally distributed with a mean of 500 and a standard deviation of 50. And then the weight of females is also normally distributed with a mean of 300. So there's a big difference between male bears and female bears based on their weight. So a typical male weighs here 68% of all bears and 68% between this, one standard deviation from the mean. Now it says approximately what would a female grizzly bear weigh with the same standard Z-score as a male that weighs 530. So a male that weighs 530 pounds falls right about here. So not quite one standard deviation above the mean. So it's a big male bear, but not a super big male bear. And they want to know what would be a female at this same point. And a comparative slightly bigger than normal, but not excessively larger than normal female. And so this is actually what you're solving for. So let's take a look. I can use the formula Z-scores AP statistics. So the actual weight of the bear is 530. We'd predict for him to weigh 500 over the standard deviation, which is 50. So we get 30 over 50, which is 0.6. Now they're saying, what if a female had the same Z-score of 0.6? Let's do her. Z is equal to AP statistics. So her Z-score is also 0.6. And her actual weight, we don't know. We predict her to be 300 pounds, and her standard deviation is 40. And so x minus 300 over 40 has to equal a Z value of 0.6 because we get the same. So really this is just an algebra question. I'm going to cross multiply to solve here. So 40 times 0.6 would be 24. And then 1 times x minus 300 is still just x minus 300. Adding 300 on both sides, we get x as 324. Now we plug this back in. Let's see if that makes sense. So would a female around 324 pounds be at about that position? It looks like, yep, that's true. So looking for 324, I find my answer. Next question. A company sells concrete in batches of 5 cubic yards. So they either sell 10 cubic yards, 15, 20, 25, and 30. They sell them in 5 sizes. And that's the probability that those are sold. So they don't evenly sell each size. This one looks like the biggest size is the least sold, and these two are the most sold. So half of all sold are these 2 middle sizes, which makes sense, kind of like t-shirts. Sell a lot of medium and larges, not a lot of smalls, not a lot of double XLs. So anyway, it says the expected value is 19.25. Now, I took the trouble of actually doing this times this, plus this times this, plus this times this, and I actually got exactly the same number. So they did us a favor and they calculated this for us. And then they found the standard deviation, which you could also do, and they did that for us. So that's kind of nice of them. And it says there's a fixed cost to deliver the concrete. So any amount of profit that the company tries to get would be calculated by 75 times the number of cubic yards minus 100. So it appears as if for every cubic yard sold, they make $75, but they have a delivery charge of $100, regardless of size of the bag. So that's what they mean by a fixed cost to deliver. So we can figure out the profit of Y, and we can calculate the standard deviation, and this is exactly a transformation question. We've had a couple of these. And so we know from taking temperature, maybe transforming from Fahrenheit to Celsius or Celsius to Fahrenheit, that when you multiply, you change the mean and the standard deviation. So when you multiply, you change the mean and the standard deviation. When you add, you change the mean. And so this is like if I just decided to increase the temperature 10 degrees of every data point, everything goes up, so the mean would go up by 10 degrees. But it doesn't change anything that talks about the variability. So the range of temperature values I measure, if I just add 10 to every temperature I measure, doesn't change the amount of range. So when you add, the mean changes, but the standard deviation doesn't. And that's what they're trying to test, if you know that. So if we expect to sell, on average, 19.25 cubic yards of stuff, and if we multiplied that, that's our X value, our expected X value, multiply that by 75, and we subtract 100, this is our expected profit. And when I do that, I get $1343.75. And so this question D is actually why my expected profit is. That's not what they asked, though. They asked for the standard deviation. So notice how my expected profit, I can multiply and I can add because this is my mean. The X value is my mean. So to change mean, I can add to the mean and I can multiply to the mean. But I can't do that with standard deviation. So the only thing that changes with my standard deviation is not when I add or subtract. It could also be subtract. I could equally have reduced the temperature of every reading by 10 degrees, and that would change the mean, but it wouldn't change, once again, the standard deviation. So the only thing I'm going to do to my standard deviation of X is multiply it by 75. And so when I take, to find the standard deviation of Y, I multiply 75 times the standard deviation of X, and I end up getting $432. So that's what I can expect. That's my expected profit, and that's my expected fluctuation of my profit. That's answer B. Now, last but not least, question 204, it says, based on a survey of 900 people, they report 60% of adults are in favor. So here you have a sample. That would be 540 people would have had to say yes for that to be 60% of the data. So you took a sample, you asked 900 people if they're in favor, which is in fact a yes or no question, and 60% said yes. If the report percent had a margin of error of 2.7, so what is the margin of error? It's the p-hat plus or minus. So your p-hat was 0.6 plus or minus 2 percentage points. So that would be 0.027. If the report percent had a margin of error of 2.7, which of the following was the closest level of confidence? So we could actually work this question backwards. How would they end up getting a margin of error of that? Well, the formula from our formula book is that they calculated this from our critical value times the standard deviation of the statistic. So if I look up in my table, I guess I can, this is not a very common one, but let's try this one first. If I look up in table B, the critical value of a 90% confidence interval would be 1.65. And the standard deviation of my statistic would be 0.6 times 0.4 over 900, and I take the square root. So when I calculate this, that would be the margin of error if, in fact, I did a 90% confidence interval. So if I did a 90% confidence interval, table B tells me that my critical value is 1.65, and the standard deviation, my statistic, is merely my p-hat times 1 minus p-hat over n, and I take the square root of all that, and I end up, when I multiply these, I get 0.027. So B is, in fact, my answer. That ended up working out nicely. Thanks for joining us.